Hello and welcome to Solar 101 with Gary the Solar Bus Guy. This introductory class is going to cover three main things. First, how to figure out how many solar panels you need for a given project. Second, what are the basic components of a solar system. And third, we're going to go through an installation and show you how it's done. This class was originally put together for a group of volunteers who were installing solar panels on a humanitarian project down in Puerto Rico. Regardless of where you are, you will learn the basics of solar energy and you'll be able to design your own system. One thing I like to say, because this is a video, you can pause it at any time, write down notes, obviously. So the big question we have when we're designing a system is how many solar panels are needed? And it's really very simple. Usually where we start is with the electric bill. If we look at the electric bill, we can see how many kilowatt hours they used in the last year. That's the main thing we're looking for. Kilowatt hours is the measurement of how much electricity is used per month or per year. And most electric bills now, if you look on the back, you'll be able to determine how many kilowatt hours were used in the last year. That's the thing that we're looking for. And then we're going to match that and produce that same amount of power by the solar panels. And how do we do that? There's a very simple equation. We're going to see it right now. You ready? Okay. The number of panels required is equal to, first thing is we need to know how many kilowatt hours they used in the previous year. And then we need to know the wattage of each panel. And that just means how many watts it makes when the sun is shining on it. And as you'll see in the next slide, every solar panel has a rated wattage. Then we have to multiply that by the number of hours that it's going to charge per year. Now we're going to dive a little deeper into this equation so we know what numbers to use. The number of kilowatt hours per year, remember I said to look that up on the electric bill. Well, there's an average amount that most people use. In Puerto Rico, it's about 4,000 kilowatt hours per year. In the mainland, it's a bit higher. But because this project is in Puerto Rico, we're going to use 4,000 kilowatt hours in our example. Then we need to know how many watts is each panel. And if you're shopping for solar panels, it will say how many watts it is. And if you already have the solar panels, as we did here, you can just look on the back and there'll be a sticker there. In this case, it's 365 watts. The number of hours of charging is what is known as sun hours. It's also known as peak sun hours. That reflects the effective number of hours that a solar panel will be charging per year. In other words, how many hours is it sitting there in the sun per year? And it's different for every climate and geography and location. And it's based on monitoring at thousands of sites all over the world. So you basically just look up the number of sun hours at the given site. There's various websites, or you can just get familiar with what the numbers are in different areas. In Puerto Rico, there's about 1,600 peak sun hours per year. Compared to Vermont, where I live, there's about 1,200 peak sun hours per year. So now we're ready to finish our equation and figure out how many solar panels we need. Now, the first thing we're going to do is we just have to convert the watts of the panels to kilowatts. And 1 kilowatt is 1,000 watts. So all we're doing is moving the decimal point. Why are we doing that? Because we have to make sure that these units match. What we do is multiply these two together. 1,600 times 0.365 equals 584. Now we're going to divide these two numbers, and what do we got? 6.8 solar panels. All right, so our equation tells us 6.8 solar panels, but we have to account for a few things. First thing is, obviously, we can't have a 0.8 solar panels, so we're going to round up. We'll start with 7. Then we're going to add another 10 to 20%. That's because solar panels are pretty cheap today. And it's better to have a little bit more solar panels than you need than not enough. Then we want to think about, are the people going to possibly increase their energy use in the future? And if they are, we would add some more panels for that. Another thing we want to do is think about, is there any shading, or are the solar panels pointing in the best direction? Because that number that we use of the sun hours of 1,600, that number assumes that the solar panels are in an optimal site, meaning they're facing the right direction, which is generally south when you're in the mainland. and that they don't have a lot of shade on them. If they do have some shade and they're not pointing in the right direction, then we have to add some more solar panels to account for that. And lastly, it always helps to have an even number of solar panels. If you're making a rectangle of solar panels, it's easier to make it look nice if there's an even number. So in this case, we started with 6.8 solar panels from the equation, and we're probably going to end up using 8 or 10 solar panels. So again, here is the magic formula for figuring out how many solar panels you need. The kilowatt hour per year demand over multiplying the wattage of each solar panel times the peak sun hours per year. Then you add about 20%. All right, so we did it. And guess what? Now you can design your own system and you could figure out how many solar panels you would need at your house. Well, all you need is your electric bill, figure out how many kilowatt hours you used last year, and make a rough estimate of your peak sun hours, knowing that 1600 is on the high side, 1200 is more on the average side, and just do the simple math. Let's do one more example together, shall we? We're going to use an example house that uses 10,000 kilowatt hours a year, so that's a bit more than the house in Puerto Rico. And we're going to go to Colorado, where there's about 1,400 peak sun hours per year. And we're going to use 400-watt solar panels. Let's take a look at the equation. We're just going to take the 10,000 kilowatt hours per year and the 0.4 kilowatts per panel and the 1,400 peak sun hours per year in Colorado. And what do we get? 10,000 divided by 0.4 times 1,400. And the answer is 17.8. After we round up a bit and account for those things that we discussed, this house would require about 20 to 22 solar panels. So there you have it. We did it. You are now a solar system designer, and you can figure out how many solar panels are required for small and large systems too. Let's do one more quick example for fun. Did you ever wonder how many solar panels it would take to make all the electricity in the United States? Let's do it. It's the same formula that we just used for one house. We're going to apply it towards the whole country. The United States uses about 4 trillion kilowatt hours per year, and we're going to use 500-watt solar panels, and we're going to go with an average of 1,500 peak sun hours per year because we're going to put the solar array in a nice sunny spot. Okay, so let's do the math. There you have it, folks. The number of solar panels required to make all the electricity in the United States is 5 billion and a bunch of threes. Now, what does that really look like? If you figure out how much space it would actually take, it comes to a square, believe it or not, that is only 140 miles on each side, roughly 18% of the state of Arizona. All right, well, we learned how to figure out how many solar panels are needed, whether it's for a home in Puerto Rico, a home in Colorado, your home, or the entire country. Now we're going to go over the basics of a solar system, hardware, and how to install them. One of the awesome things about solar is the systems are very basic. There's really only 2 main components. Solar panels make electricity when the sun shines on them, and the only thing is that the solar panels make DC energy or direct current energy, and our houses use AC or alternating current energy. So we have this thing called an inverter, and the inverter just converts DC to AC energy. That's really it. Many systems do not even have batteries. There's just the solar panels and the inverter and the house. In our case, we have batteries because the purpose of this system is to make sure that people still have power when there's a power outage, because as we know, there's a lot of power outages in Puerto Rico. And the houses that were selected on this project were people who have medical needs and have a really vital need for electricity when the power goes out. So we do have batteries. Now, in previous years, we had this basic type of system. There's one thing missing from this. As you can see, there's no way for the energy to flow back to the grid. There's nothing to do with the extra power. This is the way the systems have been installed in the previous years in this project. Well, this is the 5th year of the project, and one of the really exciting things about it is that now, starting this year, the systems are net metered. And what that means is if the batteries are full and the house is using some of the power, but not all the power that the panels are making, the extra power can go back into the grid and credit the person's account and save them money. It's a huge improvement over the previous systems. It just means that the people who are getting these systems are going to save a whole bunch of money in addition to having power when the power goes out. Let's take a look at the hardware that we're using in these systems in Puerto Rico. We're using 365 watt panels, and the systems have between 8 and 14 solar panels. You can take the wattage of each panel, multiply it by how many panels to figure out the array size. The inverter and battery that we're using in this system is made by a company called Dynes. I listed some of the specs here. And the battery stores energy, so there's power at night when a cloud goes by and during power outages. One of the really great things about this inverter and battery system is that it's all integrated and made by the same company. Whenever that's the case, it's just usually a simpler installation. All right, now for the fun part, we're going to mount the solar panels on the roof. That is the main work that we're going to do in this project. Thanks to ISO Solar, who is doing a lot of the wiring of the inverters down inside the houses. I consider putting the solar panels on the roof to be the fun part, and that is what the volunteers on this project are mainly focused on doing. When we mount solar panels onto a roof, there's a bunch of hardware components that we use. We're going to take a look at each one, starting with the roof surface. There are brackets that mount onto the roof. Now there's different types of roof surfaces, and it's very important that you use the right kind of bracket that's made to attach to that particular type of roof. In Puerto Rico, there's a lot of corrugated metal roofs, and for those, we are using this type of bracket. It's called an S5 Corru bracket. Also, some of the roofs have a different shape. This is called a PBR panel, and these are the types of brackets that we use for that. So every 4 feet or so, we're going to mount a bracket and an L-foot. You can see over here there's some brackets that have been mounted, but the L-foot hasn't been put on. Once the L-feet are on, then we mount the rail to the L-feet. So we have the brackets. On top of the brackets are the L-feet, and on top of the L-feet are the rails. What comes next? The solar panels. Now, before we attach them down on there permanently, we have to wire them together. So let's take a look at how that's done. You might see that underneath the solar panel, there's this box here. So what are those boxes that are mounted under the solar panels anyway? Well, there's 3 different types of devices that can be mounted under solar panels. The most basic one is called a rapid shutdown device, or RSD, and that is basically a safety device. There is a switch down on the side of the house that communicates with the RSDs, and if anybody wants to turn off the system for safety reasons to service it, or God forbid if there's a fire or something like that, all you have to do is turn that switch off down on the side of the house, and all the RSDs disconnect themselves completely from the rest of the system, and there's no live wires anywhere. The next type of device is called an optimizer. The optimizer does a bunch of things. Probably the most important thing that an optimizer does is it reduces the effect of partial shading. Without an optimizer, if just one solar panel has some shade on it, it acts as a bottleneck and it slows down the energy flow in the whole system. With an optimizer, if a solar panel has some shading on it, it takes itself out of the system and the energy bypasses that solar panel, effectively increasing the production of the system. The third type of device that can go under a solar panel is what we call a microinverter. And that just means that each solar panel has its own inverter. In the other type of system, there's one inverter for the whole system, and it's usually mounted inside the house. Now, for these systems here in Puerto Rico that we are installing, we are using RSD, or rapid shutdown devices. Actually, making the connections is very simple because the wires have MC4 connectors on them. You can't plug them in backwards or the wrong way. The important thing is that you have to make sure that you hear and feel the snap, and that means that it's locked in. So let's take a look at the really simple wiring. Each solar panel has 2 wires coming out of it, basically a plus and a minus. Then there is the RSD device, And that's going to have 4 connectors on it. 2 of them are going to go to the solar panel, and as you'll see, the other 2 are going to go to the rest of the system. The first thing we're going to do is connect the RSD to the solar panel. Then we can connect all the solar panels together by connecting the RSDs together. This is what we call a series string. They're all in a series line. Once we've connected all the solar panels together, we install what is called the home run wire, which brings the wire all the way back to the beginning so we can connect to the rest of the system. After the wires are connected, we're ready to mount the solar panels down onto the rails, and that's what the clamps are for. The clamps that go in between the solar panels we call mid clamps, and the ones that go on the end, guess what? We call them end clamps. It's very important to go over a few safety concerns. When you're installing solar panels on a roof, chances are you're going to be climbing on a ladder. Now, in this project, all the buildings are just 1 story and they're not very steep, so that's good. If anybody's not comfortable and doesn't want to be on a ladder or a roof, you certainly don't have to. There's plenty of work to do on the ground. Anytime you're going to be on a ladder, there should always be somebody at the bottom holding the ladder for you. That's very important. Don't ever go on a ladder by yourself. And never go up on the roof by yourself. There should always be a group of people up there together. When you're on the roof, obviously you want to stay away from the roof edges. Also, the roof can get hot, so make sure you wear gloves and be careful of your knees and your hands when you're up there. All right, we did it. In 3 days, we installed solar systems on 6 homes. I hope you learned something from this class. Please support Let's Share the Sun. By the way, if you want to know a little bit more about this project, it's an ongoing project to install solar systems on homes in Puerto Rico that have medical needs that require electricity. As you know, there's a lot of power outages in Puerto Rico, and when the power goes out, people who have medical needs, well, quite honestly, sometimes they die because they can't use their medical equipment. Let's Share the Sun has this awesome program to help those people out and install solar systems for them so they can continue to run their electric medical devices during a power outage. Many homes have been done, but there's still a lot more work to do. I encourage you to go to the Let's Share the Sun website and support their work. If you want to get in touch with me for any reason, my contact information is there. By the way, I do help people in the mainland go solar. If you're thinking about putting solar panels on your roof, give me a call. I work in most states and I can help you out. All right, this is Gary the Solar Bus Guy signing off. I hope you enjoyed Solar 101.